In this video, I'd like to talk about the math question of the day for January 23rd, 2023. And we need to simplify this expression where we have I showing up in multiple places, and I is just the square root of -1. So we are simplifying a complex number expression dealing with division. So essentially, we are dividing complex numbers, though we also have multiplication on the bottom. So the knowledge needed to solve this problem essentially relies on your knowledge of complex numbers. Have you studied how to carry out the arithmetic of complex numbers? And if so, then you should be able to answer this. And that is often taught in Algebra 2, but it depends what order your school goes in. So at this point, go ahead, pause the video, see if you can work this out, and even if you're not sure what to do, at least try for a couple minutes, and when you're ready, go ahead and unpause the video and we can go through the solution together. Now at this point, I will assume that you have tried this problem, and before we jump into this, if you do have any suggestions for future problems of the day, please feel free to leave those suggestions as a comment. Now, to solve this problem, we essentially need to carry out the multiplication in the numerator and denominator first, and then from there we can do the division of the complex numbers. So in the numerator, we can just distribute this I to both terms, but in the denominator, we actually have to multiply out these two complex numbers using distribution or the FOIL method. We will distribute the 2 to both, and we will distribute the I to both. And in the numerator, we have I times 10, which we can just write as 10I. This is minus 12 times by I times by I again, so we get minus 12 times by I squared. And I squared, if we take the square root of -1 and we square each side of that, the square root and square cancel, and we just get back -1. So we can replace this I squared with -1, though we can do that in the next step. For our denominator, we have 2 times -1, that's -2. 2 times 4i, that would be 8 i's. Then we have I times by -1, that would just be minus 1i, and I times by 4i would be 4 times by I squared, 4i squared, and we know I squared is -1. So let's now substitute in -1. We will essentially lose the I squared and the sign will flip. So we have 10i minus 12 times by -1, or plus 12, since negative times negative is positive. And for this plus 4i squared, this will just become 4 times by -1, or minus 4. So we get -2 minus 4, and these like terms we can combine to get 7i. And we'll rewrite in standard form with the real part first. We have 12 plus 10i, and in the denominator, we have -6 plus 7i. Now, to actually carry out this division, we essentially want to remove any imaginary numbers from the denominator. And the way to do that is to multiply the top and the bottom by what's called the conjugate of the denominator. And remember, a conjugate of a complex number is a fairly simple process. We take the sign of our imaginary part and flip it. So if it's positive, we make it negative. And likewise, if it was negative, we would make this plus 7i. And we do that in the top and the bottom, since this fraction right here is really just 1, since something divided by itself is always 1. So we're not changing the value of our expression here. We are just changing how it looks. Now, this part can be a little bit tedious, but we need to distribute again. The 12 will go to both. The 10i will also go to both. So we do 12 times by -6, which would be -72. 12 multiplied by -7i, we get 70 plus 14, that's 84, so we get -84i. Then we do 10i times by -6, which would be -60i, and 10i times by -7i, we get -70 multiplied by I times by I, or I squared. And in the denominator, we do the same thing. But in the denominator, we actually do get a nice simplification, and that's the whole point of multiplying by the conjugate. Since notice, we actually have a difference of two squares here. Now, we do minus 6 times minus 6, that's positive 36. Minus 6 times by minus 7i would be positive 42i. And then we do 7i times by minus 6, which would be minus 42i. This is that simplification we are looking for. And 7i times by negative 7i would be minus 49, and we have an I squared. Now, combining like terms and replacing I squared with negative 1, we can simplify everything. We still have this minus 72, but now instead of subtracting 70i squared, this becomes minus 70 times negative 1, or plus 70. And right here, minus 84i minus 60i, this would be minus 144i. Now in our denominator, these middle terms will cancel each other out, so we just get 36 and minus 49 times by negative 1, which would be plus 49. And we can simplify everything. Notice the imaginary part is no longer in the denominator. All the i's are in the numerator. So rewriting this, minus 72 plus 70, that would be minus 2. We have minus 144i. And in this denominator, when we add 1 to this, we get to 50. And 50 plus 35 would just be 85. So it looks like this right here will be our final answer. But if we want to write it in standard form, we have the real part first, minus 2 over 85. Let me just rewrite that. And we have minus 144i over 85 here. So this right here will be our fully simplified answer.